Hey there, and welcome. You ever grab a package of chicken or a bag of salad and you open it up days later and you're just like, wow, how is this still so fresh? Well, that's exactly what we're diving into today. We're going to unpack the amazing kind of invisible tech that's working hard inside our food packaging.
I mean, it's a question we've all asked ourselves, right? You're standing there in the grocery aisle, you see that perfectly red meat or that super crisp bag of lettuce, and you gotta wonder. It's not magic. Not at all. It's actually some really cool science and engineering, all designed to fight a very specific battle.
All right, so let's get right into it. To really get a handle on the solutions, we've got to know what we're up against. And the enemy? It's food spoilage. I mean, from the second that food is picked or prepared, the clock is ticking. It's a race against time for sure. So your food is basically under attack from a few main bad guys. First up is oxygen. That's what makes your sliced apples turn brown or makes oils and fats taste, well, just off. Then you've got the microscopic invaders. We're talking bacteria, yeasts, and molds all trying to have a party. And on top of that, food can dry out, which gives you freezer burn, or its own natural enzymes can just keep on ripening it until it turns into mush. It's a tough world out there for fresh food. So, with all those things trying to ruin your food, what's the first line of defense? Well, engineers figured out the most basic solution was to control the one thing that's always there, the air. The atmosphere right around the food itself. Okay, so before we jump into the really high-tech stuff, let's talk about the most basic method, the one you see literally everywhere, shrink wrap. All this really is a physical barrier. It's great for, holding a bunch of bottles together or just keeping dust and dirt off. But when it comes to fighting those major bad guys, oxygen, microbes, it really doesn't do much.
So, to actually make food last longer, we've got to level up. And that brings us to two main strategies for controlling that atmosphere. The choice is pretty simple. You can either suck all the air out, or you can swap the air that's in there for something better.
Let's talk about vacuum packing first. It's pretty straightforward and honestly, super effective. You just suck out all the air. By getting rid of the oxygen, you're basically cutting off the life support for most microbes and hitting the brakes on that chemical decay. Think about hard cheeses or cured meats. That's vacuum packing. But there's a catch, right? You can't do this with delicate stuff, like a loaf of bread or potato chips. They just get completely crushed.
And that leads us to the second, much more clever approach. It's called modified atmosphere packaging, or MAP for short. Instead of just removing the air, you replace it with a custom blended cocktail of gases. Now this is where it gets really cool. Take a look at this mix for red meat. You'd think they'd want to get rid of the oxygen, right? But nope, they actually pump in a high oxygen mix. And why would they do that? Well, it keeps the meat that bright cherry red color that we all think means fresh. Then they add some carbon dioxide to stop the microbes from growing. It's like creating a perfect, custom-made life support bubble just for that steak.
But here's the thing. Just setting up that perfect atmosphere at the factory isn't the end of the story. Things can still change inside that package. So we've got to go to the next level. What if the packaging itself could join the fight? What if it started to do some of the work?
And this is where we see a huge leap from just a dumb container to a truly smart system. We're talking about active packaging. It's not just a passive barrier anymore, not just a plastic wall. The package itself is now an active player inside, constantly working to keep that environment just right.
So how does it do that? Well, it's got a whole toolkit of tiny helpers. You've definitely seen these, even if you didn't know what they were. You know that little white packet in a bag of beef jerky that says, "Do not eat"? That's one of them. It's probably an oxygen scavenger, sucking up any leftover oxygen. Or it could be a moisture absorber. Some packages have things that release a little bit of ethanol vapor to stop mold on bread, or others that absorb funky odors. Some can even release antimicrobial stuff over time. It's pretty wild. And here's what's so amazing, just how powerful this stuff is. Remember MAP, the gas flushing technique? That might still leave a tiny bit of oxygen, maybe up to 3%. But an active scavenger? It just keeps on working, long after the package is sealed. Look at this claim from Mitsubishi. They say their scavengers can get oxygen levels down to less than 0.01%. That's basically zero. It's a total game changer in terms of effectiveness. Okay, so we've gone on a bit of a journey here, right? From simple plastic wrap all the way to these smart, active systems. So let's take a second and put them all side by side. It'll give us a really clear picture of how they compare. Yeah, this table lays it all out perfectly. You can really see the evolution. You start with shrink wrap. That's just about holding stuff together. Then you've got vacuum packing, the brute force method. Just get that oxygen out of there. Gas packing, our friend MAP, is way more sophisticated, creating that perfect custom bubble of air.
And then you have active packaging, the smartest of the bunch, where the package itself is dynamic and works 24/7 to protect the food.
So, okay, we've talked about all this cool tech, but besides just keeping our food looking pretty in the fridge for a few extra days, why does any of this really truly matter? Well, the answer is huge. It connects to a massive global problem.
1/3. Just let that sink in for a second. According to research, about 1/3 of the food the average household buys just gets thrown away. I mean, that is a staggering amount of waste.
And that, right there, is the real reason this matters so much. That's the payoff. All this invisible tech we've been talking about, the special gas mixes, those little do-not-eat packets, it's so much more than just convenience. By giving us just a few extra days before our food goes bad, it becomes a crucial weapon in the fight against food waste. It means all the water, all the energy, all the land that went into making that food didn't just go to waste.
So that kind of leaves us with one last thing to think about. You know, as our tech gets even smarter and as we all demand more sustainable options, what's next? What's the next big evolution for the packaging that keeps our food safe? What will that future look like? Anyway, something to chew on. Thanks so much for tuning in.